you may actually be working your sum and difference formulas by going in the opposite direction. So we can simplify the expression by going in the reverse direction of the sum and difference. So what I mean by that is this. If you take a look at example number 4, we have cosine of 53 degrees, cosine of 37, plus the sine of 53, sine of 37. This is basically them laying out your sum and difference formula for you. What we have to figure out is what the angles added or subtracted together, or which formula this came from. So look at this 53 degrees as being your alpha, your 37 degrees as being your beta. So 53 is alpha, 37 is beta. So if you look at the problem written this way, cosine alpha, cosine beta, plus sine alpha, sine beta. Now the question is, which formula on your sum and difference formula did this come from? So if you look at your formula sheet, notice it does look a lot like it's going to be your cosine sum or your cosine difference formula. So notice if you look at your cosine difference formula, the cosine alpha minus beta, cosine alpha, cosine beta, plus sine alpha, sine beta. Notice this is coming from your cosine difference formula. So now what I can do is I can plug in that 53 degrees for alpha minus 37 degrees for beta. And we can simplify it. So 53 minus 37 is going to give us the cosine of 16 degrees. Now, 16 degrees is not an angle from our unit circle, so we cannot simplify this anymore. This is as simplified as we can get. Obviously, if it was a unit circle angle, then we'd have to plug in the value from the unit circle. So this is what I mean by you can work these problems in the reverse direction. You just need to recognize which formula it's coming from. So now let's take a look at number 5. We have the sine of 20, cosine 80, minus cosine 20, sine 80. So again, look at 20 degrees as being your alpha, 80 degrees as being your beta. And rewrite it. Here's sine alpha, cosine beta, minus cosine alpha, sine beta. So then looking on your blue formula sheet, which formula does this come from? Is this coming from, it's not, notice your cosines will have your two cosines multiplied together, the two sines multiplied together. The sine sum and difference formula has a sine and a cosine mixed together. So when you look right here, notice this is coming from your sine difference formula. So then this is equivalent to your sine of alpha minus beta. So then I can plug in 20 degrees for my alpha, 80 degrees for the beta. So then this is equivalent to the sine of negative 60 degrees. Now, is 60 degrees one of the special angles from our unit circle? Yes. So now we need to evaluate this. So now be careful. It's negative 60 degrees. What quadrant is negative 60 degrees located? 4. So then down here in quadrant 4, what do you know about sine? Is the sine going to be a positive or a negative? Remember, all students take calculus. Negative. So I know it's going to be negative. So now the question is, what is that unit circle angle? What is the y-coordinate at 300 degrees or negative 60 degrees? What is the y-coordinate down there? So it's either going to be square root 3 over 2, square root 2 over 2, or 1/2. Square root of 3 over 2. Okay? Yes? If you look, don't be tricked, your cosine. If you look at your cosine sum and difference formulas, even though it's a cosine sum formula, in the formula itself has a subtraction. It's opposite in the formula. Okay. So the tangents are pretty obvious to recognize. So we have tangent of 80. So here's my alpha. Here's my beta. So there's tangent alpha plus tangent beta. So notice without having to rewrite the whole thing with alpha and betas, notice this is coming from your tangent sum formula. So this is going to be equivalent to the tangent of alpha plus beta. And if you plug in 80 for alpha and 55 for beta, it's the tangent of 80 degrees plus 55 degrees. So 80 plus 55 is going to give me 135 degrees, which is from my unit circle. What quadrant, first of all, are we located? Remember, going kind of back to that first, when we were doing the first unit, location, location, location. Get your location down. What quadrant is 135 degrees located?
2.
2. So now the big question is, going back to your all students take calculus, is tangent positive or negative there in quadrant 2? It's going to be what? Negative. So remember, 135 degrees is a member of the 45 degree reference family of pi over 4. So what is the tangent of your pi over 4s, or the tangents of the 45 degrees? It's going to be negative what? 1. Okay? So questions on 6. So number 7, again, we have the tangent of 40 degrees minus tangent of 10 degrees. So the tangent of alpha minus the tangent of beta. Notice that's coming from your tangents difference formula. So that I can simplify this down to the tangent of 40 degrees minus 10 degrees, which will give me the tangent of 30 degrees. What quadrant, guys, is 30 degrees located? 1. So we know everything's positive in quadrant 1. So now the question is, what is the tangent of 30 degrees? Now remember, 30 degrees in radians is your pi over 6 family. So what is the tangent of 30 degrees going to be equivalent to? Is it 1? Is it square root of 3? Or is it square root of 3 over 3? Square root 3 over 3. Again, get to know your unit circle. All right? Any questions on when you work the tangent sum and difference formulas backwards? So now, these formulas, guys, just like we did in Unit 1, the problems can be either applicable to unit circle, which is what you had your homework on, or your favorite triangle problems. So not only do you have to work these formulas involving the unit circle, you also have to be able to work them using your triangles. So with the conditions that they're giving you, what you're going to do is you're going to draw a reference triangle for the two angles in the appropriate quadrants with the conditions that they're going to give you. Label your sides of your triangle using your SOHCAHTOA. And again, to find your third side, you're going to have to use your Pythagorean theorem. Okay. So, ladies and gentlemen, this is what it's going to look like when you have sum and difference problems involving triangle. They're going to give you something about the sine of alpha or cosine or tangent. So they're telling you that the sine of alpha is 5 over 13. Remember, alpha is an angle. This inequality gives you the location of the angle. So you want to draw a triangle for this one angle. Now the question is location, location, location. This inequality is saying that this angle is going to be between 0 and pi over 2. So what quadrant would I be sketching my triangle? What quadrant is between 0 and pi over 2? 1. Because remember, here's your 0, here's your pi over 2. So again, I'm just going to draw my triangle and label this angle as my alpha. So now they're telling you that the sine of alpha is equal to 5 over 13. By your SOHCAHTOA, what sides of the triangle does sine represent? Opposite and the hypotenuse. Remember, this numerator is your opposite. The denominator is your hypotenuse. So I can label 2 of the sides of my triangle. So the opposite of alpha is 5. The hypotenuse is 13. So now using your Pythagorean theorem, or if you remember your Pythagorean triples from geometry, the adjacent side, does anybody remember what it would have to be? Well, then we'll have to use Pythagorean theorem. 13 squared is equal to 5 squared plus b squared. What is 13 squared? 169 equals 25 plus b squared. Remember, 13 squared is 169, 14 squared is 196. They just reverse that 6 and the 9. So when I subtract 25, it's 144 is equal to b squared. So b is going to be equal to 12. So any questions, guys, on how I labeled that triangle with the 3 sides? So now notice they're giving you some other conditions. Now they're telling you that cosine of beta is negative 3/5. So you want to draw a second triangle. Now, what are they telling you about angle beta? Again, remember, the inequality is giving you the location of the angle. So they're telling you that this angle has to be between pi over 2 and pi. So what quadrant would this angle have to be located? 2. Because here's your pi over 2, here's pi. So there's triangle beta. Now, what are they telling you about cosine of beta? Cosine of beta is negative 3/5. So going back to your SOHCAHTOA, what sides of the triangle does cosine represent? Your ka is the what size? It's the adjacent over the hypotenuse. So we need to label the adjacent side as 3. The hypotenuse is 5. Where does the negative sign go? Is the hypotenuse going to be negative, or is the negative x side of the x-axis negative?
Negative x side of the x-axis.
Negative 3, right. Remember, the hypotenuse, guys, is always positive. Now, if you remember your Pythagorean triple, or you have to use your Pythagorean theorem again, what now is the third side of the triangle going to be? 4. So 3, 4, 5. Okay? So that's how you get started with the triangle problems. Any questions on how I drew or set up my triangles? Now let's start answering the questions. Now they want you to find the cosine of alpha minus beta. So from my blue sheet, cosine of alpha minus beta is the cosine alpha, cosine beta, plus sine alpha, sine beta. Always copy that formula, guys, on the problem that you're working on. All right? So now, ladies and gentlemen, what I usually do before I start substituting, I know that the sine of alpha is 5 over 13. What I do from this triangle is I set up the sine, the cosine, and the tangent ratios. So sine of alpha is 5 over 13. Now looking at this alpha triangle, what is the cosine ratio going to be? The cosine ratio will be what? Well, cosine is the adjacent over the hypotenuse, correct? So it's going to be your 12 over 13. Tangent, remember by your SOHCAHTOA, is the opposite over the adjacent. So that's going to be 5 over 12. So what I do is I set up the 3 ratios from each of the triangles before I start substituting into the formula. Looking at your second triangle, cosine of beta is negative 3/5. Sine of beta, going back to your SOHCAHTOA, is the opposite over hypotenuse. So that's going to be 4/5. Tangent of beta, remember your SOHCAHTOA, tangent is the opposite over adjacent, which is negative 4/3. So all I've done at this point, guys, is from the 2 triangles that I drew, I've set up my sine, cosine, and tangent ratios using my SOHCAHTOA. Any questions on where I got these ratios from? Now I'm ready to plug things into my cosine difference formula. What is the cosine of alpha? We found the cosine of alpha to be what? 12 over 13. Cosine of beta. Now go to your beta triangle. The cosine of beta was actually given, which was negative 3/5. Plus, sine of alpha was actually given to you, which was 5 over 13. Sine of beta, we found the opposite over the hypotenuse to be 4/5. So any questions on how I plugged in those trig ratios? Now entering that lovely world of algebra, where multiplying and adding by PEMDAS, what do you have to do first? You have to multiply. So 12 times negative 3 is negative 36. What is 13 times 5? 13 times 5 is 65. Plus 5 times 4 is 20 over 65. The denominators are the same, so now I can go ahead and add those numerators together. So negative 36 plus 20 is negative 16. So there's your answer. So ladies and gentlemen, when you're dealing with the sum and difference formulas from triangles, you've got to draw the two triangles that with the two angles, label the three sides of the triangle using your SOHCAHTOA. So now, look at B. Same triangles, look at the sine of alpha plus beta. So again, from my sine sum formula, this is equal to the sine of alpha cosine beta plus cosine alpha sine beta. You guys go ahead and do your substitution and see if you can come up with this one.